Okay, so let's go ahead and talk about limiting factors in population ecology. So here I have a population of elephants, and there's going to be a few reasons why this elephant population cannot continue to grow exponentially, right? There's going to be a limit on nutrients, on the amount of energy, which energy is food. So there'll be like a competition for food and resources. There'll be competition for shelter or water or refuge from predators. So limiting factors are the things in an ecosystem that basically prevent a population from growing exponentially. This is what keeps a population at or near carrying capacity. So here in logistic growth, we saw in my previous video about carrying capacity. So limiting factors would be things like low food supply. So this is so cool. So let's think about right here. As the population grows exponentially, so like lots of abundant food right here, that leads to what's like exponential growth. Oh, tons of food. Oh, the population is growing. But right around here, we see that growth begins to slow. So as growth begins to slow right here, this is where we have an increase in population density. There's more and more individuals fighting or competing for the same resources. That's going to have intense competition happening starting like right around here. When you start to see there's less growth, that means that less resources per individual, making it harder or more of a struggle for survival. Things like disease. As population density increases, disease can spread easier. And right now, I'm recording this during the pandemic of 2020. And so you can see when we talk about social distancing, spreading out makes it harder for disease to spread. So if you have high population densities and you have lots of crowding, disease can spread much easier. And that will limit how big a population can grow. Predators, so the more you have, the easier it is for predators to hunt. Limited space. I once saw this thing about some birds that lay their eggs in the knot holes of trees. So think about a tree that has like a hole, like Winnie the Pooh gets stuck in. And they lay their eggs in those knot holes. Well, once all the knot holes are occupied, any other young mother birds who need to lay their eggs, if there's no more knot holes in the trees, they have to lay their eggs out in the open, either on a branch or on the forest floor, which now puts them at risk for predation. So there's limited space or limited shelter for animals that makes it harder to survive as you increase that population density. And then nutrient availability. This is also important in like plants for like soil nutrients. As plants grow, they take nutrients from the soil. Or if you think about like the quality of food that an organism is able to find. So as your population density increases, it's harder to get enough nutrients for survival. So all of these are examples of limiting factors, things that are going to limit how big a population can grow. So this is what I was mentioning earlier. As a population approaches carrying capacity, its growth rate slows. It slows down because it's harder and harder to survive as you reach that carrying capacity. So if we look at, this is exponential and logistic growth, just a quick summary here. So the larger the population gets, the faster it grows. So in exponential growth, this would be without limiting factors. It can grow exponentially as if it had unlimited resources. But in logistic growth, the larger the population gets, the slower it grows because of those limiting factors. So let's go ahead and compare two populations real quick. So here we have population A and population B. And we can see population A has a smaller or lower population density compared to population B has a greater population density. There are more frogs per unit of area in population B. So if we have here, let's see which population, A or B, is going to have more intense competition for this food. So if flies are available, we're going to see that population B is more going to have the consequences of competition are going to be stronger in population B. Competition for this limited amount of food will have more of an impact in B. There will be more starvation and more deaths compared to population A. Now, which population is more likely to have disease spread? Well, that's going to be population B. The more dense you are, the easier disease can spread throughout a population. Okay. And then we have which population is going to be easier for predators to find? Well, again, that's going to be population B is going to be more at, I don't know what, at risk, or I don't know what the right word is, but more susceptible to predation and predators. Just because there's more of them, they're going to be easier to be hunted. So predators will have a greater impact on population B. Now, let's say there's like a flood that comes though, like enormous amounts of rain and the rivers overflow and there's flooding. Now here, does population density really matter? No, both populations, A and B, will be affected by natural disasters. So that isn't really dependent on population density. Now, things like pollution, air pollution, water pollution, soil pollution, etc. Pollution is also something that it doesn't matter the density of the population. Individuals will both be affected by pollution regardless of population density. So when we classify these two types of limiting factors, we have this one with things like natural disasters, particularly, or pollution, are called density independent limiting factors. And density independent limiting factors, oops, just kidding. And then we have density dependent limiting factors, which were the ones with competition, predation, and disease. So here, let me move my face and let's talk about these two definitions. So here in the pink down at the bottom, density-dependent limiting factors are limiting factors of a population wherein large, dense populations are more strongly affected compared to small, less crowded populations. So competition is going to have a greater impact on a large population, or disease will have a greater impact on a large, dense population, and so therefore disease, competition, predation are examples of density-dependent limiting factors versus density-independent limiting factors are factors that affect the size of a population independent or regardless of the population density. A natural disaster is going to affect the population size regardless of how dense that population is. So those are your density independent limiting factors. And I think that is the end of my PowerPoint. All right, good job.